calculate the response of pressure, temperature, velocity, capacitance, you can do that. We don't do that at the moment. You have a PNL as well on the second one, but we do PL. So just go to PL, just put name, I just change to ILS because I'm using ILS to calculate. Then I click OK. So what we do next is have this window. So ILS, this one. You see the type is classical. Classical means use just a spinner. Classical with thermal, so we have the temperature and spinner as well. Steam injection is just for dedicated for steam. So we put the steam quality or percentage of the steam to water at the surface. And we like to know whether the steam goes into the bottom perforation or not. So we need to adjust the steam quality probably. Threshold lock is dedicated for this threshold tool. So we usually either classical or classical with thermal. Method is zone. So we do by zone. Remember, we define calculation zone and then we have inflow zone. So the changes of the flow can only happen in front of inflows. So between inflow will be straight line. That's why we call it zone. So when you have some changes in front of the leak, you put inflow in front of the leak.
Okay.
Yeah, perforation is automatic. So that's the zone approach. In between inflow will be straight line. The changes only happen in the inflow zones. Continuous, this is used when you do the temperature. As remember, when you do the segment, so segment per segment from bottom to top or top bottom, so that's one is continuous method. So that's why we use continuous also. If we use the temperature, because you like to put the model of temperature going per segment per segment. But we use spinner now, so just use a zone. Slip model straight, yeah, just follow the correlation, but we don't use because single phase. The option, we don't do that one at the moment. Go to spinners. So we click on ILSR. If you have more than one cable speed, you will be having some list and you choose the mnemonic for the cable speed. And then I go to reference channel. Why we need to have reference channel? Because we have several passes, so we need to choose which one for calculation. So we define reference channels. So temperature, remember as I mentioned, slowest don't pass. So it will be done 3.
Slowest don't pass.
Yeah. So remember this is D10, it's digital temperature, not the temperature. Don't worry. And pressure, I would like to use all to make average from all 6. So I just click on log data. So it will be average of all 6 passes. And that's it. Capacitance density, I'm not using it. Just to make the simple one first. So we need to define pressure temperature. That's the minimum. So reference channel and match view, usually I always take this one. It's good to see the matches. So then click OK. Oh, sorry. The ID, you have some ID here. Yeah, if you have some C1, C2 from caliper, XY caliper, or if you have MFC import, so you might have the different stuff here. So from the top to bottom is the priority. Excel, okay. So you will have a reference channels user view. Define because we define pressure and temperature, so there will be 2 curves on the interpretation user view. Yeah. ILS is the name of the interpretation. So this is the reference channels. So we use DON 1 for temperature, DON 3 for temperature, and pressure average for the pressure reference channel. Okay, so what we do next, just follow the icon on the left. So we did info, we go to spinner zone. So we go to spinner zone. So we need to make the yellow zone. Where to put the yellow zone? I use ILS. So I like to put in the sun, but yeah, of course we don't need that, but to get a better data and velocity in the water, I like to put in the water zone, even though we know it's producing gas only. So I put one in the water and the other one in the gas zone. So then you can interactively put the zone here. So I can click spin, interactive calibration zone definition, spin. Then I like to choose stable ILS, stable cable speed, stable density. Yeah, ILS CPL capacitance density. So I'll just put maybe 3860 to 3870. And then I put the second one in the water. Click spin again. 3930, 3940. And then I adjust the orange. You click on the orange and it will be interactively edited. So I move down the top one until the top of water level. And the bottom orange I increase to the water level as well. Yeah, because I like to use the top yellow from the water level to the top. So I use the orange. Yeah, I don't really need to move the orange up to the top here. When it is the most top, then it will be used all the way up. If it is the most bottom, then it will be all the way down. So you don't need to define that, the top one. That should be applied. And if you like to change the depth manually, you can click edit. And I go to calibration. For example, I like to have 3860 to 70, 3950, 3940. You can change this one. It's subjective, but looking at the data, remember stable cable speed, stable demand, stable density.
So at the moment we are choosing a depth to calibrate. Is it? So that's why we are not putting the yellow from top. We are just putting when it is.
Yeah,
How do we choose the yellow?
Uh, that's why stable inline, stable cable speed, stable density. So you can have more. That's your call. Doesn't matter. Just average over that. But I guess 10 meters should be enough to cover this fluctuation. So if you put more, yes, you can be statistically better. But yeah, at least I just look at this one, it should be quite stable. I don't want to use this one. Yeah, because this one is not correlate. So I don't want to use that one. And yeah, some of the changing there, but at the bottom, yeah, it's fine. So you can see it's like, you might see the changing of the red as well, but yeah, more or less should be fine because we don't care about the water basically.
So the orange is the application of yellow,
Yes.
right? So why do we drag the orange until the water level?
Yeah, because I like to put the top one is coming from the gas.
Okay.
So I like to apply in the gas, which is starting from the water level,
Okay.
right? Starting from water level up to the top. But since this is the most top, then everything else will be used this one. So we don't need to drag this one up to that, right? And the water uh, slope and threshold from the yellow, I need to apply in the water. So then I like to extend this one to the water level. And below that one, everything will be used the same because this is the most bottom one.
Okay.
Makes sense? Yeah. So that's why we need to put the orange interactively. You can actually change the orange, I guess, not in this one. But you need to go to calibrate, then transition. We can change the depth. But I like to have in the mouse, using mouse is easier. Because you don't remember, I mean, you don't need to remember the depth at him. So I just prefer to use the mouse. Okay?
So from
Yes.
by doing this, what we get?
Next one.
Belum masuk.
Okay. So we are choosing that area to be calibrated.
Yes,
Right.
the yellow. So the top red here is the top yellow.
Okay. Hmm.
Also.
Mm. We choose sleep and then we can.
I can make it bigger. You okay, right?
Oh.
Oh,
Oh, you have to draw it here. You have to like
okay.
click and drag.
Saya buat
42
Is there anywhere we can record all this?
is recorded.
Got PowerPoint.
lupa.
PowerPoint. Then
Video. Video.